In this video, I'm going to go over finding the maximum or minimum and range of quadratic functions. Why did I say or maximum or minimum and range? Well, because we're talking about parabolas, right? And parabolas either open up, in which case they would have a minimum point, right? The vertex, or they open down, right? And they have a maximum. So you're either finding the maximum or the minimum. So mostly we're focusing on finding the range. Because that's all we need for parabolas. Why? Well, the domain in these cases is always going to be all real numbers. Not always, because you could, could have fractions and, well, we do have fractions here, but we could have some examples like this. See? Because you can't have a 0 in that denominator. I get rid of that, but we're not doing one of those in this video. So, domain is all real numbers for all of these. So we're just finding the range. And that's all we're doing. We're not completely graphing it. We're not solving it for the x-intercepts, although you could do that if you wanted to. All right, so for this green one, f of x, we have negative 5x squared plus 9x minus 1. Now, first thing you got to do when finding the maximum or minimum is determine whether you're looking for the maximum or the minimum. Well, a is negative 5, right? That comes from the standard form of a quadratic equation is ax squared plus bx plus c, right? A here, in this case, is negative 5, which means what? It means that the parabola is going to be opening downward, and it's going to be pretty steep, right? Because 5 is a larger number than 1, right? So we're looking for what? Maximum. We're looking for the maximum. Okay. Well, how do we find that? Well, let's find the axis of symmetry first. Axis of symmetry would be this dotted line right here, going right down the middle. We find the x value of our vertex, and we can find the y value. And that is negative b over 2a. That's how you find the axis of symmetry. Right? So negative b, negative 9. Got my a's and b's confused there. Negative 9 over 2 times a, which is negative 5, right? All right, so negative 9 over 2 times negative 5 is negative 9 over negative 10, which is just 9 over 10, right? All right, now to find that maximum, we need to take that axis of symmetry, that x coordinate, and plug it in for x. Negative 5 times 9/10 squared plus 9 times 9/10 minus 1. All right. Equals y, right? All right, what's 9/10 squared? 81 over 100. I'm multiplying that by negative 5. 9 times 9 is 81 over 10 minus 1. Okay. Now, instead of multiplying 81 times 5, I think it's easier to cross-cancel these, right? Because since this is multiplication, we can divide first. So what's 100 divided by 5? 20. 5 divided by 5 is 1. So we're left with negative 81 over 20 plus, okay, we want these denominators to be the same. So we multiply it by 2 over 2. So 10 times 2 is 20. What's 81 times 2? 162, right? You can check my math on that. Now, 162 minus 81, well, we just kind of did that, is going to be 81 over 20 minus 1. Now, 1 in 20ths is going to be 20 over 20, right? So, 61 over 20. That is the maximum. That is the maximum we were looking for. Now, we use that to show what the range is. So, since it's the maximum, the range includes all lower numbers, which means we're including negative infinity. And we go all the way up to 61 over 20, and we include it, so we put brackets there. That is our range. And the domain is all real numbers. Got it? All right. Let's erase this and go to the... All right, now for the blue one, g of x. What's our a, right? It's positive, so we're opening up, right? So we're looking for the minimum this time. What is our axis of symmetry? Negative b over 2a. Okay. That would be positive 2/3. Cross cancel that again, right? Divided by, and there's a reason I'm writing it this way, 3/2. I like to write it this way so I can keep track of exactly which fractions I'm dividing, because dividing by a fraction is the same as multiplying by its reciprocal. So I take the reciprocal of 3/2 and we get 2/3, and I multiply it. And that gives us 4/9. Is our axis of symmetry. Take that 4/9, plug it back in. All right, 3/4 times 4/9 squared minus 2/3 times 4/9 plus 7. All right, let's see what we got here. 4/9 squared is 16 over 81 times 3 over 4. Two-thirds times 4 over 9 is 8 over 27. Okay. We can cross cancel these, huh? Divided by 4 is 1, divided by 4 is 4. Divided by 3 is 1, divided by 3 is 27, I believe. Yes. 27 times 3, 6, 7, 8. Yep. So we're left with 4 over 27 minus 8 over 27. Wow. That worked out nicely. We got common denominators there. So we're left with negative 4 over 27. See what happened there? Okay. Oh, this is crazy. In order to get common denominators, we have to multiply 27 times 7. 7 times 7 is 49. 2 times 7 14 plus 4, 18, so 189. Let's just place that with 189 over 27. And we get some crazy number. 185 over 27. Now, this can be divided by 3 and 9. So its factors are 3, 3, and 3. And this does not divide by 3. How do I know that? Because the digits add up to a number. They add up to 14, right? 14 does not divide by 3, so therefore 185 does not divide by 3. So this is in simplest form. Can't reduce that fraction down anymore. Hard to believe that is actually our minimum, right? So how do we write the range? Brackets, right? Because we're including the 185 over 27. Something like 6.8, I believe. If you plug that into your calculator, goes to infinity, right? All right, let me erase this, and we just have one more. All right, last one, the red one. Now, usually I save the most difficult for last, but in this case, this is actually the easiest one. Why? Well, if you notice, this one is in vertex form, right? So the vertex is just hk. In this case, we have negative h right there. Negative 4/7 is negative h, and 8/11 is k. So a vertex is 4/7, 8/11. That was easy. Don't have to do negative b over 2a right there. We don't even need the x-coordinate. We have the, is it the maximum or the minimum? It's the minimum, right? Because a is positive again. We're opening up. So it starts at 8/11, includes it, and goes to infinity. And that's how you do it in vertex form. Thank you for watching.